Hello to everyone and welcome to KET Academy. In today's video, we are going to be focusing on mechanics. So if you are a student writing any concours such as the medicine concours, polytechnic, public works, ENS, INSET, just to name a few, I mean any concours, then this video is going to be very helpful to you. But the main focus will be on those writing medicine. So question 1 says, what is the instantaneous velocity in meters per second of a coconut that falls vertically from a tree after a fall of 2 seconds? So the first thing to do whenever you are given an equation is to collect your data and draw your diagram if possible. Then drawing our diagram, we know that this is our coconut and we know that our coconut is falling. Then this is the direction of fall. This is the direction in which it's falling. Now we know that our acceleration always acts downward. The acceleration due to gravity, which is g, always acts downward. Now we have been given a time. We know our time is 2 seconds, and since it started from rest, then initially the velocity was 0. So we are going to look for an equation of motion relating time, acceleration, and initial velocity. So we know from the equation of motion, v equal to u plus at, and since our u is 0, so this is going to go away. We'll be left with v equals to 80. Now our acceleration is acceleration due to gravity, so we are going to replace our acceleration with g. Okay, and substituting or doing our numerical application, our g, we know our g is 10 and the time is 2 seconds, so in this case we are going to get 20 meters per second. Now if in any MCQ question you are given answers options with, maybe let's say the first answer is having they use acceleration g due to gravity, they have used 9.8, and let's say another option they have used 10 meters per second, then it is very obvious that the answer option with acceleration due to gravity 9.8 meters per second squared will be the correct answer. So we are going to look at the options. The first one says 5, the second one says 1, the third says 2, and the fourth says 20. So that is our option, that is our answer. Then the correct answer here, the correct option here should be D. The next question says that a rocket of mass 1000 kg rises vertically with an acceleration of 4.0 meters per second squared. What is the total thrust force applied by its engine, taking g to be 9.8 meters per second? So we see clearly that here our acceleration due to gravity g was given, so you are not allowed to use the order. So 9.8 meters per second squared, and our normal acceleration has been given to us too, the acceleration of the rocket. So drawing our diagram here, we are projecting, this is the rocket that is being projected upward. We know downward, the weight acts downward, mg acts downward, and also this is the direction of the thrust force, so we are going to represent it as the thrust force. That is the direction, and we know acceleration due to gravity acts downward. So we know from Newton's second law, it states that the sum of all the forces should be equal to ma. So here we are going to consider a direction which we are resolving to. So if we resolve this, we are going to have T, the thrust force minus the weight mg. The weight should give us ma. So we are looking for the thrust force, so the thrust force will simply give us m into a plus g. So I actually took mg that way, and since m is common, I factor it out. So our thrust force will simply be equal to 1000 times Our acceleration was 4 plus, and the acceleration due to gravity was 9.8. So doing this, 4 plus 9.8 is 13.8 times 1000 give us uh, 13,800. So if we look at our options, then the first one says 4. So C says 1.4 times 10 to the power 4. So if we convert this to standard form, we're going to have 1, 2. So we'll definitely move the decimal point like 1, 2, 3, 4. So since 8 is greater, so we're simply going to have 1.4 times 10 to the power 4. Since we're talking of force, the unit is Newton. So clearly our options, the correct option there is C. So that is the correct option, C. Now question 3 says a block of mass 2.0 kg is attached to a spring of spring constant K equal to 8.0 newtons per meters, undergoing simple harmonic motion of amplitude 0.1. What is the maximum speed? So here, if we draw our diagram, then we have our body. This is the body. This is the block. This is our block. So this is our block. Since it is undergoing simple harmonic motion, at one point in time, it might oscillate to that position, or another point, it might oscillate to that position. Now, we have been asked to look for the maximum velocity, but we know that the relationship between maximum velocity and displacement, the maximum velocity will occur at this point, and when displacement here is 0, here at this point the displacement is 0 and the velocity is maximum, so we know that from Vmax, for any simple harmonic motion, Vmax is given as omega, the square root of r squared minus x squared. So clearly we see here that since x is 0, then x squared will simply be 0, and the square root of r squared will give us r. So our Vmax will give us omega r. Since we are talking of a simple harmonic motion and a spring is involved, then our omega will be, so this formula can simply be simplified to omega, the square root of k all over m. So doing our numerical application, we are going to see that Vmax will be the amplitude, which is the radius, will be, apparently this is a radius r. So the amplitude r will be 0.1 times our k, the spring constant is 8, now divided by the mass was 2 kilogram. So this will give us 0.1 times 2, because 8 divided by 2 give us 4, the square root of 4 is 2, so this will be 0.2. We're looking for the speed, so it will be meters per second. So now let's check our options to see if we have the correct answer. So the first one says that, so looking at our options, we see that 0.20 meters per second. So this is our answer. So this is the correct option here. Now question 4 says that the graphic representation of the function y equals to f of x with functions x equals to 5 sine omega t and y equals to 5 cos omega t. So here we have our x to be equals to 5 sine omega t, and y to be equals to 5 cos omega t. So we want to see the relation, what this function actually describes, or the graphical representation. So to look at it in a better way, we have to simplify these our two functions to be in the form y equals to f of x. So simplifying that, we know from basic trigonometric ratio that sine squared theta plus cos squared theta is 1. So since these two functions are in terms of trigonometry, we're going to try to put it in that form to simplify. So if we look at this, if we multiply, if we squared x, we're going to have x squared to be equals to 25 sine squared omega t, and if we squared y, y squared should be equal to 25 cos omega t, cos squared omega t. So if we add these two, so we're going to have x squared plus y squared to give us. Now if we factor out 25, we're going to have sine squared omega t plus cos squared omega t, and we know from trigonometry this will simply give us 1, so this will be 25. So x squared plus y squared will give us 25. So this can also be written as x plus 0 all that squared plus y plus 0 all that squared equal to 5 squared. So if we erase that, we'll have 5 squared. So we will compare this to equation of a circle. So we know that r plus x naught all that squared plus y plus y naught all that squared to give us r squared. So clearly you see that this is a circle of center x naught, y naught with coordinates 0 0 0 0, and the radius here is 5. So let's look at our options. The first one says a straight line. First, this can never be a straight line because we know even if we were to sketch just x equals to 5 sine omega t, is going to give us a sinusoidal wave. So an ellipse is obviously not an ellipse because the coefficients of x squared here, they are all 1. So a Lissajous figure, it's not a Lissajous figure, a circle. So definitely it's a circle because this is an equation describing a circle. So even at this level you could end, and come and check your solutions. So the next question says, two bodies of different masses both falls from rest from the same height above the floor at the same time at any moment. Which one of the following statement is not correct? So we have two objects here. Let's say this object A and this another object, let's say object B. But we see clearly that the question says M1, these are the masses, is M2. We know that M1 is different from M2. So now, which of the following statement is not correct? Now let's look at the options. We select from there. So the first one says they have the same velocity. Now, if they are falling from the same height, because the question clearly says they fall from the same height, let's say they are falling from this height, then their velocity will simply be equal. We know from v equal to u plus 80 plus 80. We know they started at the same time. Initially, all of them were at 0, and we know a also is constant since they are falling. G is the acceleration due to gravity. Since t is constant and a is constant, then v will be constant. So v is the same for the two objects. And this one does not relate with mass, so mass will not affect this equation. So mass does not affect the velocity. So they'll have the same velocity. So option A is correct. Now option B, they have the same acceleration. It's quite obvious they are falling with acceleration A equals to g. So object A will be falling with the acceleration g, and object B will also be falling with acceleration g. Therefore, they'll have the same acceleration. Now they have the same height from the floor. So we know from S equals to UT plus a half AT squared. AT squared. Our time, they started at the same time. The acceleration, they're falling with the same acceleration. A half is constant. Initially, they were at 0. Therefore, the height, which is the distance, is constant. And you can even visualize it. The question says two bodies of different masses both falls from rest. They're falling from rest. It means their initial acceleration is 0. So they're falling from that particular height. At that point, they'll have the same height from this relation. So C is also correct. Now this says they have the same kinetic energy. We know kinetic energy is a half mv squared. It's a half mv squared. And the option says kinetic energy 1 will be equal to kinetic energy 2. This is very wrong because first of all, m1 is different from m2, so this can never be correct. So just this option is the incorrect options that we're talking about. Now for E, they have the same speed. So if they have the same velocity, therefore they'll have the same speed, because the speed is simply the magnitude of the velocity. So the option for question 5 will be D, because kinetic energy solely depends on the mass. We know kinetic energy is directly proportional to the mass. So changing the mass will change the kinetic energy. That is why option D is correct. Now for question 6. A cyclist is going at 20 meters per second. What is the angular velocity of the ant on one of its tire if the tire has a radius of this? So we know that our angular velocity v angular is equal to omega r. It's omega r, and we know omega r is in rad per second, and r is in meters. In this case, it means that our velocity will be in meters per second because rad is a unitless. So in this case, we're looking for our omega. Since we're looking for the angular velocity, so v omega will be equal to velocity all over divided by the radius. So our velocity there should be 20. Now divided by the radius was 0.34. So doing our calculation, we are going to have 20 divided by 0.34. So this will give us 50. So our angular velocity will be 58.82 rads per second. Rads per second. So let's look at our options. The first one says 59. So obviously that's the correct answer. 59, because I've kept the answer in two significant figures. So we move ahead. Question 7 says a small object of mass m equals to 1000 milligram is released to slide without friction on a smooth inclined plane, making an angle of 30 degrees with the horizontal. Take G to be 9.8. So let's represent this on our diagram. So we have our smooth horizontal plane making an angle of 30 here. So this is our object. This is the object. It's sliding downward here. So this is the direction of slide. So we know this component will be mg sine 30, and this component will be mg cos 30, and opposite that will have the reaction. So resolving all the forces, and downward we have mg. Now looking at our options, the first one says the acceleration of the object is 49 times 10 to the negative 2. Now from Newton's second law, the sum of all the forces should be equal to ma. So applying that, we're going to have this is it means that here we have this the direction of the force F. So it means sum of all the forces should be equal to ma. So summing our force, we'll have mg sine 30 plus F to be equal to ma. So since it was on a frictionless we'll assume that the friction here, let's say the friction here is 0, since it was on a frictionless plane. Friction is 0. Now here our force is also 0. We're looking for the acceleration, so the acceleration will simply be mg sine 30 divided by m. So our m is simply going to cancel. We'll be left with g sine 30. So our g is 9.8, so we have 9.8 sine 30. Sine 30 is 0.5, so divided by 2. So it will be 9.8 divided by 2, which will be 4.9. So it's 4.9. So meters per second squared. Meters per second squared. Now looking at the options, it says A, the acceleration due to gravity is 49 times 10 to the negative 2. So it will be like, if we put this to standard, or if we put it to standard form, then option A is wrong. The reaction of the inclined plane on the object is equal to 8.48. So we know that to calculate our reaction, the reaction is actually equivalent to mg cos 30. So that is the reaction. So we know our m is 100 milligrams. So we have to convert it to kilogram, which will be 100 times 10 to the negative 3 kilogram. Now times 9.8 times 9.8, now times cos 30. So doing our numerical application, we are going to get cos 30 times 9.8, now times 100 times 10 to the minus 3. So we are going to get 0. So our answer will be 0.8487. So newtons. So let's look at the option B and compare. So it gives us 8.48 newtons. Okay, which is not the answer. And option C says the acceleration of the object is equal to 4.9 meters per second squared. So we see that option C is the correct one, because we solved when we were looking for option A, we saw that the acceleration was 4.9, not 49. So obviously our answer will be option C. So our answer is option C, because we did the calculations already. Now question 8 says that a girl throws a stone of mass 1.0 kilograms at a speed of 2.0 meters per second. At the moment it hits the ground, the stone has 200 joules of kinetic energy. What is the height of the cliff from where she throws the stone? I think this day is not there. Is she from where she throws the stone? So if we draw a diagram, we'll see that here is a girl with a stone. She throws it, and this is now the final position of the stone. They're asking for the height of the stone. So they're asking for this height. Now we know from the law of conservation of energy, the mechanical energy at the top of throw, the mechanical energy at the top will be equal to the mechanical energy at the bottom. So we're going to resolve it separately. Mechanical energy at the top is equal to the potential energy plus the kinetic energy. Now since the girl throws the stone with an initial velocity of this, therefore the kinetic energy at the top will simply be, therefore the potential energy at the top will be mgh, and the kinetic energy will be a half mu squared. So we have resolved all the energy at the top. Now looking at the mechanical energy at the bottom of throw, which will be The potential energy, we know that at the bottom, the mass, the stone will cover no height. So at this point, our h, the height is actually 0. So the potential energy here will be 0. But we have been given the kinetic energy. The value has been given in the question, which is 200 joules. The kinetic energy now at the bottom. Now equating this, we are going to have mgh mgh plus a half mu squared to be equals to ke at the bottom. Ke at the bottom. So we're looking for the height. We're looking for h. So making h subject, we're going to have making h subject here. We're going to have h to be equal to the k kinetic energy at the bottom minus a half mu squared divided by our mg. So doing our numerical application, we're going to have that the kinetic energy at the bottom is 200 minus a half m. Our m there is 1. So a half, and our u is 2. 2 squared should be 4. 4 divided by 2 should be 2. So divided by g. So we're going to consider our g to be 10 in this case. So our height will be 200 minus 2 divided by 10. So it will be 19.8 meters. So now let's look at the options. So clearly we see that our answer will be option B. Option B. The next question says that a car of mass this is moving with a speed of 60 meters per second. The driver applies his brakes to reduce its speed to 20 meters per second. How much heat is released during the slowing down? So we know from the work energy principle, we see that the work done here will simply be equal to the change in the kinetic energy, and the work done here is the work done to release the heat. So the work done here will be change in Ke, and the change in Ke will simply be equal to a half m into our u squared minus our v squared. So we'll have a half, the mass is 1 times 10 to the power 3. Now times u, initially it was at 60, so we have 60 squared minus 20 squared. So doing our numerical application, we're going to have 60 squared minus 20 squared will give us 3200. Now 3200 times 1000 is going to give us 3,200,000 divided by 2. So it gives us 1 million. So it will be 1.6 times 10 to the power 6 joules of energy. So if we compare this with our answers, then we're going to see that the correct options will be option D. Now for the last question, question 10, it says that is a particle of mass 2.5 times 10 to the negative 2 kilogram is describing a uniform circular motion of radius 0.5 meters in a horizontal plane. It makes 300 revolutions per minute. Its linear acceleration in meters per second squared is, so in this case we know that linear acceleration is omega squared r, but our omega is 2 pi f, so omega squared will be 4 pi squared f squared. But the frequency, which is our revolutions per second, was given in revolutions per minute. We're simply going to change that to per second, which will be 300 revolutions per minute. We know that 60 seconds makes 1 minute, so this will give us 5 rads per second. 5 rads per second, that's our frequency. So substituting in our formula, we're going to have the linear acceleration to be omega, we have, which will be 2 pi. The 2 there will become 4 since we are squaring. Pi squared, and now it will be 5 squared. So our linear acceleration will be times the radius. The radius was 0.5. So doing our numerical application, we're going to have 4 times 0.5 will give us 2 pi squared times 25. 2 pi squared times 25. So this will give us 2 times pi squared times 25. So give us 493 meters per second squared.